Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. Today, in this session, I am going to teach you how to solve JEE Main PYQ on the topic Strength of Bases from General Organic Chemistry of Class 11. Okay, let us start the session. So, you are finding a question here, right? When it is asked, it appeared in 2018 JEE Mains examination, right? And what is the question? The increasing order of basicity of the following compounds is, okay, basicity. What is the meaning of basicity? Okay, basicity. It is the tendency to donate a pair of electrons to H plus. Tendency of a species. Species here represents, it can be a compound, it can be a molecule, it can be ion, whatever it is. Okay, ion or a neutral molecule or even atom also. So tendency of a species to donate a pair of electrons, okay, to H plus. That's called as what? Basicity. When does a species act as a base? When it can donate a pair of electrons to H plus, we say that it is acting as a base. Okay. So, which will be strong base? If the given species has more tendency to donate the lone pair, then it is strong base. Then it is considered as a strong base. So now when can you say that it is strong base? Okay. Strong base means having more tendency, which is the species having more tendency to donate lone pair to H plus, to a proton. Okay. So when can it donate? It will have more tendency to donate lone pair. If it is having availability. So we can say that more the availability more the availability of lone pair, more the tendency to donate. If there is more availability, then it can donate, right? If there is less availability, it cannot donate. Okay. So more the availability of lone pair should be more available. Then it can donate. If it is donating that lone pair to H plus, we say that it is strong base. Okay. What is that? Strong base. If the species is having less tendency to donate the lone pair, then we say that it is weak base. So less tendency means less availability. Okay. So more, you have to remember that more the availability, more tendency to donate. More stronger the base, less availability, less tendency to donate, weak base. Okay. So from these concepts, we are going to decide or we are going to solve the questions from JEE Mains PYQ. Let us see. Here, four options are given. Let us see among these four options. In the first option, let us see the first option. What is given? CH2 double bond CH CH3. Okay, CH2, right? NH2. Here. Now, around nitrogen, what is present? Around nitrogen, what is present? You are having two hydrogens and another one alkyl group. So this is what tendency does it possess? It is plus I group. Ability to push the electron. Okay, ability to donate the electron. So now what it is doing? CH2, CH, CH2, double bond CH2. What it is doing? It is donating electron density in this way. It is pushing the electron density. So it is showing plus I. So when it is pushing electron density, what happens to this lone pair? Lone pair electron density increases. So due to electron donating group, EDG means what? Electron donating group. What are electron donating groups? Generally electron donating groups are plus I groups, plus M groups, and hyperconjugation. Due to electron donating groups, the groups which shows plus I, plus M, hyperconjugation, what happens? Electron density on nitrogen increases. Electron density on nitrogen increases. So that what happens? So that basic strength increases. Basic strength increases, right? So when does the basic strength of amine increases? This is amine. Which amine? Primary amine. What amine is this? This is primary amine, right? Now let us see the next one. So first basic idea we have regarding this first option. Let us move to the second option. In the second option, what is given? CH3, CH2, CH double bond NH. What is this amine? Okay. So now you are, what is the hybridization of nitrogen here? Here the hybridization of nitrogen is, how many sigma bonds do we have? 2 sigma and 1 lone pair. 2 sigma 1 lone pair means sp2 type of hybridization. Here if you see this, this is sp3 hybridized. So we know that on increasing the s character, electronegativity increases. On increasing, okay, s character, electronegativity increases. If electronegativity increases, then automatically nitrogen being more electronegative, it holds this lone pair. This lone pair is folded effectively by nitrogen because nitrogen is undergoing sp2 type of hybridization. More the s character. Here in sp2 hybridization, what is the s character? S character is 33.3%, whereas P character is 66.6%. So more the S character, more the electronegativity, more tendency to hold the pair of electrons. So more the tendency to hold the pair of electrons, less the tendency to donate. Less the tendency to donate, less basic it is. Understood? It will be less basic. So when compared to 1, 2 is less basic because nitrogen here is undergoing sp2 hybridization. Okay, let us see the third one. Okay, what is given? Third one. Here it is given CH3C NH2 double bond NH. Here it is a special case. Carefully you need to observe it. Now you have lone pair of electrons here and you have lone pair of electrons here on nitrogen, both the nitrogens. Both the nitrogens is having lone pair of electron, but what is happening here, this lone pair, let us see in yellow color lone pair, right? These are in resonance. Okay, these are in resonance. So this pair of electrons don't participate because they are involved in delocalization. This pair of electrons are not donated, not responsible for the basic nature. Which pair of electrons are responsible for basic nature? This pair of electrons. So responsible for basic nature. For basic nature of this compound. So this pair of electrons are donated to, see blue color, in the blue color we are finding this pair of electrons. This pair of electrons are responsible for basic nature. That means they are given to H plus, they are donated to H plus. So when they are donated to H plus, see, let us see NH2, now NH, right? So they are donated to H plus. When they are donated to H plus, what happens? It becomes NH2 plus. NH2 plus. Okay, when it becomes NH2 plus, now you see A, you have the configuration for resonance A, double bond B and C. A double bond C has lone pair. So we got the configuration, or we are finding the conjugated system. We are finding the conjugated system. As we are finding the conjugated system, what happens? Lone pair of electrons, as electrons have negative charge, they are pushed towards the positive charge. Now what happens? This pair of electrons are donated here, and this pair of electrons move in this direction. So what happens? You get another resonating structure due to resonance, due to delocalization of these pi electrons. We get another resonating structure. So if such phenomena happens, that means after donating lone pair of electrons, the formed positive charge, if it is resonance stabilized, then automatically this will have more basic strength. Why it is having more basic strength? Why we are saying that this compound is having more basic strength? Why? What is the reason? Because after donating pair of electrons to H plus, the formed species is resonance stabilized. Due to resonance, we say that stability increases. Stability increases. That means after taking H plus, okay, after accepting H plus, after taking H plus, that means after donating lone pair of electrons, what you get? You get conjugate base. Conjugate base. So we say that if conjugate base is, if conjugate, so conjugate acid, if conjugate acid of a base is more stable, if the conjugate acid of a base is more stable, then the base is strong base. Then the base will be strong base. So based on this concept, why it is more stable? This more stable is due to resonance stabilization. So that is the reason why the conjugate acid of this base is more stable. So that is the reason why it is strong base. So third option, see, third molecule. So third molecule, after donating this lone pair of electron to H plus, it is becoming resonance stabilized. So this conjugate acid is more stable. That is the reason why it is more basic in strength. Okay, strong base. Coming to fourth option. So what is given? Let us see fourth one. CH3, CH2, NH, CH3. Okay. So here this is a secondary amine. Which amine it is? Secondary amine. Because in ammonia, two hydrogens are substituted with alkyl group. Substituted with whom? Alkyl group. So this is secondary amine. On both sides we have plus I group, and here also we have plus I. So both will push the electron density towards nitrogen, so that this electron pair density increases. Already we have studied that due to plus I group, that is electron donating group, what happens? Electron density on nitrogen increases, so that the basic strength increases, right? So now from this first highest which is possessing highest basic strength, third one is possessing highest basic strength because its conjugate acid is highly stable. So 3 greater than, after that you will find this is primary amine. This is also, this is sp2 hybridized, whereas this is sp3 hybridized. Here this is also sp3 hybridized. So after 3, the next molecule which is having more acidic strength is fourth molecule, because you have 2 plus I groups and the nitrogen is sp3 hybridized. Okay, both CH3 and ethyl groups are pushing the electron density towards nitrogen, so that the electron density on nitrogen increases. So highest is 3, after that 4, after that 1, because this is sp3 hybridized. When you compare 1 and 2, in the first molecule nitrogen is sp3 hybridized, whereas in the second molecule nitrogen is sp2 hybridized. Who will hold the electron pair more effectively? sp2 carbon. sp3 carbon will not hold the electron density as like that of sp2 carbon, so it will donate the electron density. So first molecule is more basic than second molecule, right? So first molecule is more basic than second molecule. So this is the increasing order. So you will get the second as the correct answer. Second option as the correct answer, right? Let us see the next question. Asked in 2019. Arrange the following amines in the decreasing order of basicity. So 3 are given: first molecule, second molecule, and third molecule. Let us see the first molecule, right? In this molecule, nitrogen is here. This nitrogen, you are given bonds. So pyridine molecule. Right? So here there will be lone pair. Now you see, is this lone pair of electron involved in resonance? No. Where is this lone pair? This lone pair is in sp2 hybridized orbital. Okay. And beside this, you have a pi bond. Is there pi bond? Yes, this pi bond. Let us draw that pi bond. This pi bond is in this. This is the pi bond, right? That is the pi bond. Now this pair of electrons on nitrogen is in sp2 hybrid orbital, and this p orbitals where pi bond is involved. This is p orbital, pure p orbital, this is pure p orbital, and these two are perpendicular to each other. Okay, so lone pair on nitrogen and pi bonded p orbitals of adjacent C double bond C are perpendicular to each other. So if they are perpendicular to each other, then is there possible for delocalization? No. So now here there are a pair of electrons, not, these are localized, but what is the hybridization of this nitrogen atom? This nitrogen is sp hybridized, sp2 hybridized, sp2 hybridized. Okay, so this is one condition. It is, as they are not delocalized, they are available. As they are localized, availability is there. Okay, let us see the second one, second option. Second option is given like this. Nitrogen, okay, this. Here you see this pair of electrons. You have a configuration of a conjugated system. This pair of electrons are in conjugation. Pair of electrons are in conjugation. So nitrogen, is there availability of this pair of electrons? Is this pair of electrons available for donating to H plus? No, because they are involved in resonance. When they are involved in resonance, they are forming pi bond, right? Let us draw the resonating structure for that molecule. Okay, this is one resonating structure. See, this pair of electrons which are on nitrogen are forming pi bond. Now, are they available? Not available. And this pair of electrons are involved in pi bond. So the pair of electrons on nitrogen can be taken as pi electrons. So total pi electrons in this molecule, okay, is equal to, I can take it as 6. Now it is satisfying the conditions for aromaticity. See, what are the conditions for aromaticity? First one, the molecule must be cyclic. Yes, the molecule is cyclic. The second one is continuous conjugation. There should be continuous conjugation. Yes, there is continuous conjugation. There is no breakage of conjugation. So we can say that that is a cyclic pi electron system, we say. If it is having continuous conjugation, we can say that it is having cyclic pi electron system. And the third one is every atom which is involved in the ring, every atom in the ring is sp2 hybridized, that is, it is a planar molecule. And the fourth one is, it is satisfying the condition 4n plus 2 is equal to 6 pi electron system. 4n plus 2 pi electron system. 4n plus 2 is equal to 6. N is equal to 1. So it is what type of compound? Aromatic compound. Aromatic compound. See, now you can find that here due to the involvement of this pair of electrons into resonance, this is becoming a aromatic compound. That means this pair of electrons is involved in aromaticity. So very, very much not available. Okay, we can say that electron pair on nitrogen is involved in what? Aromaticity. Due to aromaticity, what happens? Stability increases. So as they are involved in aromaticity, are they available to donate? So electron pair is not available. Not available for donation. So least basic compound. It will be least basic compound, right? Let us see the third molecule, right? Let us see the third molecule. What is given in here? It is given like what is the hybridization of this nitrogen? Nitrogen hybridization is sp3 hybridized. It is sp3 hybridized. And from this direction, what you have CH2 here, you have CH2 here. From both sides, it is donating. This is having plus I character. This CH2, this side, right side also, it is having plus I character. From both sides, it is donating. So lone pair of electrons on nitrogen increases. Electron density increases. When electron density increases, availability of lone pair increased. So when the availability is increased, it is able to donate that lone pair. Okay, so it donates this lone pair, donates because availability is more, lone pair to H plus. It is able to donate this lone pair of electrons to H plus. So as two plus I groups are pushing the electron density towards nitrogen, the lone pair of electron density increases, so it will donate. So the molecule which is having highest basic strength is the third one, because availability is more. This is sp3 hybridized. This is pushing. This is also pushing. That is, it is having plus I character. This is also having plus I character. Two plus I characters. After third one is having highest among 2 and 4 options you can see. And after this, which is having more basic strength, one is having more basic strength because the pair of electrons are not involved in resonance. They are not delocalized, they are localized. But in second, they are delocalized. So 3 is more basic than 1, 1 is more basic than 2. Okay, so you will find fourth option as the answer. Understood? Okay. So let us see the next question. When it is given 2019, you can see in 4 molecules, except here rounded, fluorine, except CH3, everything is same. Right side, if you see the molecule, everything is same. Only the difference is one. In the molecule A, you have fluorine at what is this position? Let us take 1, 2, 3, 4. 1, 4 position is called as para position. At para position, what do we have? This is para position. Fourth position is para position. At para position, we have fluorine. Here at para position, we have methoxy. Here at para position, we have nitro. At para position, we have methyl group. Okay. So if at para position, if we have fluorine, the other molecule I am not drawing. So this is the other part. Here we have fluorine. Okay. This is, I am considering this as 1, 2, 3, 4. Okay. At para position, if it is fluorine, what effect does it show? We know that halogens show both, see, halogens show both plus M and minus I. It shows both plus M and minus I, but minus I is more than plus M. This is only in the case of halogens. Only in the case of halogens. So as minus I, electron withdrawing tendency, is greater than plus M, electron donating tendency, cumulatively we take, but we take cumulatively halogens are mild electron withdrawing groups. What is this, sir? Cumulatively, taking minus I and plus m into the consideration, as minus I is greater than plus m, what we say? Halogens are mild electron withdrawing groups. So halogen, I say that F is, what do I say? F is mild electron withdrawing group. Here at at para position we have CH3. What do we have? We have OCH3. Now what does it do? It pushes the electron density through pi bond. That means it show what effect? Plus M. Plus M means strong electron donating group. Plus M group is, it shows plus M, it is strong electron donating. If it donates the electron density along this pi bond, what happens? You will have more electron density at this position, first position. At position 1, you have more electron density, so that electron density on nitrogen increases. Okay. So if electron density on nitrogen increases, because see, OCH3 is pushing electron density along the pi bond, the electron density or lone pair electron density on nitrogen increases. If it increases, automatically it will be strong base. It will be strong base. So now here we can write it as electron donating tendency or electron donating group. EDG means electron donating group at ortho or para position for these molecules. Ortho or para position increases the basic strength. Whereas electron withdrawing groups at ortho or para positions decreases the basic strength. So now you say among A and B molecule, B is having more basic strength than A, because in B molecule we have OCH3 electron donating group, whereas in A molecule we have electron withdrawing group. Coming to third molecule is nitro. It shows minus M group. Okay, if nitro is present at third molecule, let us consider this molecule. This is 1. The complete molecule I am not writing. 1, 2, 3, 4. Here what do we have? We have nitro. Okay. We have nitro. So what does it do? It pulls the electron density in this way. Okay. You get positive charge here. At first position you are having positive charge. If there is positive charge at this first position due to nitro group, you are having positive charge here. If positive charge is here, automatically this lone pair of lone pair is pulled by this positive charge. When positive charge is pulling the lone pair, what happens? Automatically this lone pair density decreases. So due to nitro group, due to strong electron withdrawing group, what is that? Nitro group, the basic strength decreases more. So it will have least basic strength because nitro group is showing minus M. Okay, so strong, we can say that this is strong electron withdrawing group. Which one? Nitro. Fluorine is mild electron withdrawing group, right? Next, coming to CH3. Okay, we can take this is C molecule, molecule C. Let us see D now. In D, if you see carefully here, 1, 2, 3, CH3. What does CH3 at para position exhibits? It exhibits hyperconjugation. Here you see. So the CH3 group, what is the CH3 group? CH3 group is showing hyperconjugation. HC means what? Hyperconjugation. Hyperconjugation is when compared to plus M, HC is mild electron donating group when compared with plus M. Okay, so we can say that it is mild electron donating. So overall we can say that electron donating groups increases the electron density, increases the basic strength. Electron withdrawing groups decreases the basic strength. Now, how many you are finding electron donating? Mild electron donating group. So B and D you can find electron donating, and among that strong electron donating, this is strong electron donating. Which one? Plus M, OCH3. So as it is strong electron withdrawing donating group, it shows more basic strength. So second one is having more basic strength among those four. So which is here among 1 and 3 you can take. And electron donating groups are present in B and D option. Strong electron donating group is present in B. Okay. So after B, you have D, electron donating group. And after D, you can find fluorine is mild electron withdrawing, whereas nitro group is strong electron withdrawing. So electron withdrawing group decreases the basic strength, right? So fluorine, as it is mild electron withdrawing, it does not pull the electron density much. It pulls only less electron density. So after that, A and the least is C. So where do you find this third option? Okay. The increasing order of the basic PKB is asked. Sorry, what is that? What is asked? PKB. So now we have found the basic strength. What is that? We have found the basic strength. Now let us write here. Basic strength, which is strong base, which is strong CaDb we have found. CaDb. This is basic strength. And we have studied that, okay, more the Kb or less the PKB, more basic strength. That is strong the basic. If PKB is less, it will be more basic. It will be more basic. So let us write the PKB values. PKB, more basic, no? So C has more PKB than A, D, B. So this is the values of PKB. Less the PKB, more basic. Less the PKB, more basic. Okay. But here it is asked that increasing order of pKb. What is this? This is decreasing order, right? What is this? Decreasing order. We want a increasing order of pKb. What is the increasing order of pKb? Opposite. C greater than A greater than D greater than B. Okay. So what is this? This is decreasing order. What we want? Increasing order. Increasing order will be what? B less than D, D less than A less than C. So where is this option? B less than D, D less than A less than C. So this will be the answer, right? Let's see the next question. 2020, 8th question. The increasing order of the basicity for the following intermediates is from weak to strong. Increasing order of basicity. Right? Already we have studied that electron donating groups like plus I, okay, hyperconjugation will increase the basic strength. Okay, electron withdrawing groups like minus I, minus M, okay, minus I, minus M will decrease the basic strength, right? Now let us see these three molecules. Molecule 1, we have a plus I group, electron donating plus I, 3 plus I groups. So 3 will be pushing the electron density in this way. As they are pushing, automatically this negative charge increases. Negative charge means a pair of electrons. Electron density increases. When the electron density increases, it can donate the electron density to H plus. Effectively, more the availability of electron pair, more the availability of electrons, more the tendency to donate. That's it. Okay. Now let us see here negative charge. Negative charge means already we know that a pair of electrons. Now we have configuration. It is a conjugated system. A double bond B, C has pair of electrons. Okay. Now this is a conjugated system. As this is conjugated system, this pair of electrons are involved in resonance. Now you see in the second molecule, whether it is more basic or first molecule, it is more basic. First molecule is more basic because the availability of pair of electrons is more. More the availability, more the tendency to donate. More the tendency to donate, more basic. Okay. Coming to here third molecule. In the third molecule, okay, you can find a CH triple bond C. This is negative charge. Due to this pair, this extra electron, we have negative charge. Now, what is this hybridization? Hybridization is, you can see this is sp hybridized. Okay, sp hybridized means S character is 50%, whereas p character is also 50%. More the S character, more the electronegativity. When you compare it with the fifth one, okay, C triple bond N, right? There are a pair of electrons here, one electron, negative charge. So negative charge. So negative charge, where is the negative charge? On carbon. And what is the hybridization of this carbon? This carbon is also sp hybridized. S is having 50%, P is also having 50% character. So both are having a sp hybridized carbon, the negative charge is in both the compounds. We have negative charge on the carbon atom, which will pull the electron density, this pair of electrons, which will pull more the electron density, or this pair of electrons are pulled more by this molecule, fifth molecule. Why? Beside the carbon, who is present? Nitrogen. Nitrogen electronegativity is 3.0, whereas carbon electronegativity is only 2.5. So beside this sp carbon, who is present in the third molecule, carbon, beside this carbon in the fifth molecule, who is present? Nitrogen is present. As nitrogen is present, it will pull the pair of electrons with more force, so that the availability is less. So among 5 and 3, which is more basic? 3 is more basic than 5. More the electronegativity, less ability to donate, less basic strength. Okay. Now, which is more basic among these? Let us see fourth molecule. In the fourth molecule, if you see, it is CH3, CH. Okay, minus. Okay. What is the hybridization of this carbon? The carbon is undergoing sp3. Now, comparatively, if you look into, no doubt about it, first molecule is having highest basic strength. Highest basic strength is possessed by the first molecule, because there are 3 plus I groups. Due to these 3 plus I groups, the availability of electrons is more on the carbon, and that carbon can donate the pair of electrons to H plus, so that it is more basic. And among these 4 options, if you see, the highest is possessed by 1 in only second option. Okay. Then after, among 2, 3, 4, in 2, the pair of electrons are delocalized. In 3, 4, 5, it is not delocalized. But in fourth molecule, we find that the carbon is undergoing sp3 hybridization, so that it will not hold the electrons more effectively, so it can donate. So after that, fourth molecule is more basic. And among 5, 3, 2, already we have seen that among 5 and 3, 3 is more basic than 5. So 3 is more basic than 5. And here, among delocalization and sp hybridization, if you see, sp hybridization makes the atom to hold the pair of electrons more effectively. sp hybridization is dominating than delocalization here. sp hybridization is dominating than delocalization. So answer will be second. Understood? Okay. So let's move to the next question. 2020. The decreasing order of basicity of the following amines is. Here you can see this is aniline molecule, first molecule. Here you find the pair of electrons are delocalized. So in first molecule, what is happening? You find the pair of electrons are nitrogen, localized or delocalized? They are delocalized. So availability is less. In the fourth molecule also, they are delocalized because they are present in conjugated system. Where they are in the conjugated system. See, hydrogen. This is a conjugated system. Already we have studied conjugated system. A double bond B, C. If C has lone pair, then it is a conjugated system. This pair of electrons are under conjugation. Not only on the right side, it is also conjugation on the left side. This pair of electrons are also in this way conjugation. On both sides, it is being conjugated. On both sides, it is being conjugated. Okay. It is delocalized on both the sides. With both the pi bonds, the lone pair is under delocalization. So in first molecule and fourth molecule, if you see, availability is less. Availability. Why availability is less? Because they are involved in the resonance. They are not available to donate, to be donated. They are not available to be donated. They, where are they? They are involved in the resonance. They are under delocalization. Availability is less in both the molecules. Okay. Next, coming to second option, already we have studied that this is pyridine molecule. This pair of electrons and the adjacent pi bond are perpendicular to each other. So this pair of electrons on this nitrogen are not involved in resonance. So we can say that these are localized, but they are present on sp2 carbon, sp2 nitrogen. Whereas coming to molecule number 3, what is that? Molecule 3, if you see, here you have a plus I group. This is plus I. This is also plus I. From both sides, it is pushing. Electron density is being pushed from both the directions, from both sides. So what happens here? The electron density increases. Electron density increases. So where the availability is more, here also this pair of electrons are localized. And due to these plus I groups, more the availability. And in the molecule number 3, if you see, the nitrogen is undergoing what type of hybridization? Nitrogen is undergoing sp3 type of hybridization. You know that if it is sp3, it cannot hold the pair of electrons, so it can be donated easily. So the molecule which is having highest basic nature is third molecule. Okay, where you can find that in first option and the second option. And after that, if you see in 1 and 4, they are delocalized, but in second, it is localized. So it is available. So after 3, you will have 2. After the third molecule, which is having more basic strength, second molecule is having more basic strength. So you can find only one option like this. And among first and 2, if you want to donate according to the options given, here pair of electrons are in resonance under delocalization, but in the fourth molecule on both sides the pair of electrons are being delocalized. That is the reason why availability in the fourth molecule is very much less, so it is least basic. It is least basic. Understood? Right? So answer will be second option. Let us move to the next question. Question asked in 2020. Right? The increasing order of basicity of the following compounds is. Now only we have studied that the pair of pyridine molecule, this is pyridine molecule, A molecule is pyridine. Okay, the pair of electrons are perpendicular to the pi bond, orbitals involving in pi bond. So this pair of electrons are localized pi electrons. What we say? Localized. But the nitrogen is undergoing sp2 hybridization, where here they are involved in resonance and that leads to aromaticity. Okay. So lone pair in the B molecule, if you see, lone pair is involved in resonance. Already we have discussed this molecule involved in aromaticity, not resonance, as well as aromaticity. So least basic. What do we say? It will be least basic. Whereas coming to the third molecule, this is undergoing sp3 type of hybridization, plus I group, plus I group. Okay. So from both directions, the electron density is pushed. So the availability of electrons on nitrogen will be very much high. So it will be highest basic. So highest basic is C and least basic is B. You can find it in third option. Highest basic is 3, least basic is B. Highest basic is C, and least basic is B. So you will have fourth option. And among A and D, so D, if you see, you are finding 2 nitrogens. Okay. And this nitrogen is not involved in resonance, but whereas blue colored pair of electrons on nitrogen are involved in resonance. But as there are 2 nitrogens and there is 2 lone pair of electrons, D will be more basic than what? A. Here also this nitrogen is undergoing sp2 type of hybridization, but there is another lone pair. Though it is involved in resonance, this lone pair contributes some to the basic strength. There are 2 nitrogens. One nitrogen pair of electrons on one nitrogen do not involve in resonance, but another lone pair is involved in resonance. But that lone pair also contributes something to the basic strength. So that is the reason why what we say basic strength of D greater than A. So overall C more basic than D more basic than A more basic than B. Least one is B, highest is C. So you can find it is in fourth option. Okay, let's see the next question. (2022). Which among the following is the strongest Bronsted base? Bronsted base, right? Now you can find here, this is CH2 CH3, that means it is showing plus side tendency, right? The CH2 CH3 shows plus side, this also shows plus side, this also shows plus side. So what is this amine? First molecule is tertiary amine molecule. What is this molecule? Tertiary amine. Okay. And this nitrogen is undergoing sp3 type of hybridization. What type of hybridization? sp3. Coming to the second molecule, this plus I, only 2 plus I groups. And this molecule anyway undergoes sp3 type of hybridization. But among the first molecule, what is that? First molecule and second molecule, which is more basic? One is more basic than 2. One is more basic than 2 because first molecule is tertiary amine. 3 plus I groups are there. 3 plus I groups. 3 plus I groups are pushing the electron density. They are pushing the electron density, pushing electron density towards nitrogen, so that the availability of lone pair of electrons on nitrogen increases. When the availability increases, basic strength increases. Amines. Here only 2 plus I groups in the second molecule. In the third molecule, if you look into third molecule, in the third molecule, this pair of electrons are involved in resonance. Okay, so they are not available. So first molecule is more basic than second molecule is more basic than third molecule. Coming to the fourth molecule, it is also tertiary amine. What it is given? Nitrogen. Okay. So bicyclic compound. What compound? Bicyclic compound. It is bicyclic compound. Now, no doubt about it, it has 3 sigma plus 1 lone pair, nitrogen. So it undergoes sp3 type of hybridization. But there are no four bonds. Are there 4 bonds? No, 3 bonds. And it is tertiary amine. Tertiary amine. That means it shows plus I, it shows plus I, it shows plus I. 3 alkyl groups are pushing the electron density towards nitrogen. So no doubt about it, availability is more. Not only that, now the bond angle here, it will be less than 109 degrees. In this molecule, bond angle will be less than 109 degrees. When the bond, actually for sp3 hybridized atom, the bond angle should be 109 degrees, 109 degrees 28 minutes. But here, due to presence of one lone pair and due to the repulsion between lone pair and bond pair, what happens? The bond angle is less than 109 degrees 28 minutes. Okay, as the bond angle is less than 109 degrees 28 minutes, there will be angle strain in the molecule. Okay, there is angle strain. There is angle strain in the molecule. Angle strain in the molecule. Strained molecule. Now, if it is donating this lone pair to H plus, now the bond angle increases. On, what you can say, on donating lone pair to H plus, the bond angle becomes 109 degrees 28 minutes. That means bond angle increases so that the angle strain decreases. Angle strain decreases. As this angle strain is decreasing on donating this lone pair, what happens? It readily donates. Yes, I want to donate. If I donate, what happens? My angle strain decreases. Okay, so what does it do? It will donate the lone pair. When it donates the lone pair, as the angle strain is decreasing, it becomes stable. So after donating, it becomes conjugate base. So the conjugate acid, the conjugate acid is more stable. So we can say, so the basic strength is more. Basic strength is more. So for the fourth molecule, no doubt about it, it is tertiary amine. And after donating this H plus lone pair to H plus, angle strain is lost. Due to loss of angle strain, it becomes free. It will be more stable. So it readily donates this lone pair. So what happens? The fourth molecule is more basic. So that will be the answer. Okay. So coming to next question asked in 2024. Question number 26. Let us see what will be the decreasing order of basic strength of the following conjugate bases. Okay. You are given first one OH. Okay, you have negative charge. OR, next one. OR. So now you compare these two. In OH, there is no electron withdrawing or electron donating group. And anyway, this pair of electrons, this negative charge is on oxygen. Oxygen hold that negative charge effectively. Okay. But when compared with OR, R what group? Plus I group. That means it pushes the electron density. What does it do? It pushes the electron density. When it pushes the electron density, the electron density, that lone pair electron density on oxygen increases. If it is increasing, it will donate easily. It will donate easily. That means among OH and OR is more basic than OH. OR minus is more basic than OH minus. Now, next coming to CH3COO minus. CH3COO minus. Now you say this pair of electrons are in resonance, delocalized, and two equivalent resonating structures are formed. What you find? Two equivalent resonating structures. Due to these two equivalent resonating structures, the species is highly stable. What is this acetate ion? Acetate ion is highly stable. As it is highly stable, it will not donate the lone pair easily. So it is less basic, less availability, because this negative charge, that means the lone pair of electrons responsible for that negative charge, they are under resonance, under delocalization. When they are in the delocalization, they are less available, less the availability, less ability to donate, less basic. And the next molecule is chlorine. This is halogen. Okay, halogen is having more electronegativity. This electronegativity dominates here than this resonance. Electronegativity dominates resonance. So this is highly stable, because halogen having negative charge. When halogen having negative charge, it gets octet configuration and it is highly stable. It is highly stable. So comparatively, chlorine is very much highly stable. When it is highly stable, does it donate this pair of electrons? No. So what we say, less tendency to donate. Less tendency to donate. Very less tendency. So least will be halogen atom. Least basic is chloride. Highest basic is OR minus here. So where is that option? Third option. Alkoxide. This is what? Alkoxide. Alkoxide is more basic than hydroxide. Hydroxide is more basic than acetate. Acetate is more basic than chloride. Understood? Okay. No doubt about it, among these four, which will be more basic? You can find alkoxide, because negative charge is present on oxygen, but there is one plus I group, so that electron density increases, so that it can donate easily. So we have only one option with alkoxide having more electron. Alkoxide occupying the first position, more basic, right? Next, coming to 2024 given. Already we have studied about these molecules. Here, this is involved in resonance. So lone pair on nitrogen, correct order of basic strength of pyrrole, pyridine, and piperidine. Okay, lone pair on nitrogen is involved in aromaticity. This already we have seen. Aromaticity in pyrrole molecule. So least basic. So this pair of electrons are not at all available. When coming to piperidine, already we have studied that this is plus I group. This is also plus I, and nitrogen undergoes sp3 type of hybridization. So in piperidine, okay, in piperidine, lone pair on nitrogen is more available. available. So strong base. So basic strength will be more. So piperidine more, pyro least. You will have third option. Already pyridine 2 to 3 times we have already discussed. This pair of electrons are not involved in resonance, they are localized. They are localized, and this is present on sp2 carbon. sp2 carbon holds this pair, so they cannot be donated easily when compared with the piperidine. Okay, piperidine is more basic than pyridine. Pyridine more basic than pyrrole. Right. Next, coming to which is least basic. Okay, which of the following is least basic? So first option, let us take CH3 C double bond O N H C2H5. If you see, this shows plus I character, but here this pair of electrons are involved in resonance. So that is first option. Second option, N, right? C2H5, C2H5 and C2H5, right? Plus I, plus I, plus I, plus I, plus I and plus I. So from three sides, they are pushing the electron density towards nitrogen. So the electron density on nitrogen increases. So it will be more basic. Okay, more basic. Let us see the third one. Nitrogen, C double bond O, CH3, C double bond O, CH, H. If you see this lone pair is in resonance with two COs. Now you say among 1 and 3, which is more basic? 1 will be more basic because it is the lone pair is only making resonance with one C double bond O. But in the third molecule, lone pair on nitrogen is making resonance with two C double bond O. So least available is in third molecule. This lone pair is least available. Lone pair is least available among these compounds. So least basic. So will be least basic. So now fourth option, let us take N, right? H, C2H5 and C2H5. Now you say it shows plus I, it also shows plus I. Both shows plus I. When both shows plus I, electron density on nitrogen increases. Lone pair electron density increases, so it can donate. So highest basic strength, if you see basic strength order, you see this basic strength order, second one is having more basic strength than 4, 4 is having more basic strength than 1, 1 has more basic strength than 3. So more the availability, more the basic strength, less the availability, less donation, less basic strength. So third one will be least basic. The question asked is in least basic. Okay. Next question, 2021. What is the question? Given below are two statements. Aniline is less basic than acetamide. So let us draw aniline. Already we have described about this. Okay, this is aniline. In aniline, we have conjugated system. So the pair of electrons are delocalized on benzene ring. Lone pair of nitrogen is delocalized on benzene ring. Benzene ring contains what? Carbons. Okay, it is delocalized on the carbon atoms, but acetamide, what is this? This is aniline, right? If you see acetamide, let us see acetamide, CH3, C double bond O, NH2. Now here also, this is conjugated system. Lone pair of nitrogen is delocalized with oxygen. Oxygen is more electronegative atom. So we can say that this is strong resonance. We say that a strong resonance, whereas resonance with carbon is less strong when compared with resonance with oxygen. So this pair of electrons are moving on to oxygen. Oxygen more electronegative atom. So strong resonance, we consider it as a very strong resonance. So more stronger the resonance, less availability the lone pair, less availability the lone pair, less basic. So this will be less basic. Okay. So who is less basic? Acetamide is less basic than aniline. Acetamide is less basic than aniline, right? So this is a wrong statement. Statement 2. In aniline, the lone pair of electrons on nitrogen atom is delocalized over benzene ring due to resonance and hence less available to a proton. Yes, statement is correct, right? Now only we have discussed that it is conjugated system and this lone pair is delocalized on the benzene ring. As it is delocalized on the benzene ring, it is not available to be donated to H plus easily. In the first option, we have compared aniline with acetamide. What is this? This is acetamide. We have compared these two. But in the statement 2, simply he is making statement that the lone pair is not available because it is making or it is delocalized on the benzene ring due to resonance and that the lone pair is not available to be donated to H plus. Yes, the statement is correct. So statement is correct. Statement 1 is wrong and statement 2 is correct. Statement 1 is false, but statement 2 is true. So this is the correct answer. So these are all the different model questions which were asked in JEE Mains previously. Okay, all the questions we have discussed. Hope so you understood it very well. Wherever you don't understand, please rewind and play the video. So that is the advantage of a video. How many times you want, whenever you want, how many times you need to go through the concept, you can simply rewind and play. Okay. Until you understand, go through that these videos so that you will be having grip on that particular topic, right? Thank you very much for watching. Let us meet in the next video with a new topic.